activity for today is direct shear by shear box test. Okay. So kita dah dapatkan the shear strength of the soil. Okay, so this is the objective. Okay, so as we stated in the objective in the manual, to determine the shear strength characteristic by using the direct shear box apparatus. Okay, so the shear strength characteristic or parameters is represented by two values we know as friction angle and cohesion value. Okay, so that is the shear strength for soil. But some soil they have kita panggil cohesionless condition. Okay, ada yang certain the other type of soil they have frictionless condition. So dia ada jenis C dan V value lah. Okay, friction angle and cohesion. Alright, learning outcome. Okay, acquire necessary skill to conduct the test. So I will show you how to prepare the sample. Okay, so this is a sample. Okay, the sand. So shear box test is suitable to use to determine the shear strength for sand. Tapi kalau the other type of soil, kita akan menggunakan triaxial test. Okay, kita akan tengok pada minggu hadapan lah. Okay, determination and analysis of shear strength parameter. Okay, so last time saya dah tunjukkan macam mana penggunaan Microsoft Excel dalam plot and analysis lah. Analysis tu plot tu kita panggil analysis lah, calculation and dan sebagainya. So you need to use the same medium, okay, Microsoft Excel to determine the shear strength parameter. Okay, so saya akan tunjukkan macam mana nanti. Tapi Microsoft Excel tu you buat sendiri, kan? So saya dah ajar macam mana how to calculate and how to plot the graph. So you do the same step lah. Okay. Now look at on the theoretical background. Okay. So the shear strength, okay, dia buat huruf T tu sebenarnya bukan T, dia tau. Simbol tau. Or the soil can be represented by column equation. So this is according to the more column failure criterion. Okay, failure criterion of the soil can be represented by the several numbers of model of criteria lah. Okay, so but we adapt the more column. Okay, more column adalah salah satunya. If you refer from, so the shear strength or tau is represented or equal to cohesion plus sigma tangent phi. Sigma is the normal stress. Okay, tangent friction angle. Okay, so total normal stress of failure, cohesion and angle of friction lah, phi. Okay, so dia bukannya vertical incline lah, phi dia. So the problem statement. So the shear box is the simplest, the oldest and the most straightforward procedure for measuring the immediate or short-term shear strength of soil in terms of the total stress. When we consider the effective stress, basically we consider the pore water pressure, because the total stress, the effective stress is equal to total stress minus pore water pressure. But in this case, we doesn't apply any pore water pressure, so kita hanya calculate for total stress, because the pore water pressure is equal to 0. And total stress is equal to, so effective stress is equal to total stress lah. So as a group, you are required to investigate the shear strength, okay, to obtain. Okay, so how to obtain? So start dengan stage of sample preparation. Okay, so normally we take the sand sample. So this is sand being provided to you. Okay. So this is the box lah. Okay, so kita ada satu lagi, the main part of the instrumentation is the loading arm. Seperti mana odometer last time, dia ada pemberat. So shear box pun ada pemberat. Okay, nanti kita akan tengok lah kat dalam. So first saya akan terangkan how the sample being prepared. Second, I will show you the equipment. But unfortunately the condition of the equipment is under maintenance. So I just show how it will be conducted lah, and I will show to you I will give you the result. Okay, as be attached in the WhatsApp group. Saya ada attach satu folder. So itu adalah contoh result lah yang kita akan dapat. Alright. Dan saya akan tunjuk juga what kind of calculation or analysis that you need to present in your report. Okay. So start with the sample preparation. So this is the box. So basically this box consists of the two parts, the top and bottom. Mold lah. This is the mold lah kita panggil lah, because our sample will be put inside here. Okay. So the sand will be compacted or loose condition. So there are dua condition kat situ. So it is depend on our design. So basically we will shear the sample. So this is shearing direction. So our sample will be split into two. But this is soil, so dia akan ada kita panggil failure plate inside the sample yang kita prepare tu. Okay. So we shear the sample and at the same time we apply the normal stress. So in this test normally we take at least 3 number of different normal stress value. Kita akan dapat. Okay, mungkin kita letak 10 kilopascal, 15 dan 20 kilopascal to get the range of normal stress of the failure. Jadi kita akan each of the normal stress kita akan tarik lah. Alright. So in order to prepare the sample, okay, so kena lekatkan lah supaya dia tak displace during the preparation. Okay, so screw balik. Okay, screw sikit cukup lah. Okay, gerak okey lah. Alright. So there are two type of method. So one of the sample is undisturbed sample dan satu lagi adalah disturbed sample. So saying is quite impossible for us to get the undisturbed sample because this is granular salt. Kan, kalau kita take, dia tak boleh punch pun, dia akan loose. Okay, but if we take the clay sample, yes, we can take the undisturbed sample. So kita akan punch to the ground macam kita buat preparation menggunakan co-cutter for odometer ataupun permeability lah. Okay, so this is the co-cutter punya apparatus lah. If we use the kita panggil granular salt with sand, for example, so kita akan use this apparatus lah. So basically, okay, so dia ada direction of the sand. Kita tengok plate ni, dia ada direction of our shearing. So kita kena perpendicular the arrangement dia. Okay, porous stone dulu, lepas tu baru letak plate yang tadi. Okay, so dia centering lah, kat atas pun sama. Okay, so kat atas tak nak letak atas ni pun tak apa lah, ataupun just nak letak macam ni pun boleh. Sama lah, the same direction, dia letak kat atas lah. So those source sample that you need to put inside the box. Okay, so this is the example of our sample now. So kita akan letak at least 3 layers. You can design how much the density of the sand that you need to conduct. So in this granular salt, there are two conditions. When kita nak simulate the compacted salt or compacted sand or loose sand, okay, it will give the different result. Okay, so saya decide untuk buat compacted sand. The difference is kalau compacted kita compact lah, kalau loose kita tak compact. Okay, so kita buat compacted. So masukkanlah. Okay, first layer. To compact lah. Betul lah. Kali is depend on how you design the density of the sand. So normally will be instructed by engineer lah. So dia nak simulate how much the density of the sand. Mungkin you boleh refer balik you punya kita panggil dry density daripada sand replacement dan sebagainya. So you boleh counter check balik. Okay, kita nak simulate the strength. So decide lah. Okay, so normally it take about 25 lah. So kira lah. Okay, so kalau nampak ada gerak-gerak the void ni, you macam usik-usik lah bagi dia rata kan. Nampak ada kan. Okay, katakanlah dah 25 kali. Alright, lepas tu you garis-gariskan lah bagi dia ada bonding contact between the first layer and the second layer, and put the another layer, the second layer. Okay, do the same thing. Okay, different is if you not compact, make the source sample is loose. So bila you compress, dia takkan ada peak. Nanti I will show the difference result. Okay, mungkin pernah tengok last semester dalam tutorial. Okay, so I compact again lah. Dan terakhir sekali. Dan baru kita letak direction. Make sure it's perpendicular to the shearing direction. Okay, dan juga post this. Okay. So that's all about the sample preparation. Nanti kita akan letak loading cap lah kat atas. Okay. Kalau tak letak yang poster pun tak apa lah, sebab dia boleh drain ke bawah. Bila kita compress dia akan mengalir ke bawah. So tak perlu letak kat atas. Okay, so this is loading cap. Okay, so loading will be pressed in this point. Okay, and then dia akan distribute evenly the loading. So what you need to measure is the size of this area. Okay, because loading will be applied in force kilonewton. So you need to calculate the area to get the Pascal, kilonewton per meter square. Alright. So the next stage adalah kita akan deliver this sample, okay, the prepared sample to our equipment lah. Okay, secara pegang macam ni lah.